Hello and welcome to second lecture in fifth chapter. We are doing at present about NumPy advanced. And in previous lecture, we have done this thing: VStack, HStack, and column stack. We also saw that there are other ways of obtaining the same thing, like this notation, or maybe this notation, or even complex. That is a HStack is used, but ultimately you get column stack and all that. But basically, only three are good enough for any task: HStack, VStack, and column stack. Okay, and you have to pass a tuple of the two arrays which you want to stack as the argument. Now, same HStack and VStack can also be obtained by concatenate. Some people prefer this because there is a single command, concatenate, and one has to remember only one thing. Even this argument, everything remains the same. Concatenate, inside you have to pass the tuple of two arrays which you want to concatenate as one argument, and you have to specify x is equal to 0 as another argument. This is in case 1D arrays are there, both these A and B. Then whether you want to do horizontal stacking or vertical stacking, still x is equal to 0 only, because this is the axis which is of original array. So if original arrays are 1D only, then obviously they have only a single axis. So the question is then how to achieve that. What is the difference? I mean, I'm saying that for HStack also and for VStack also, the command remains the same. Yes, command remains the same, but the difference is in passing these A and B. For horizontal stacking, A and B, if they are one-dimensional array, they are passed as one-dimensional only, as such, without any change. But for vertical stacking, we have to first convert them into a two-dimensional array, and then we have to pass them. Okay, so we have to, in a way, reshape them and then pass them. Otherwise, the command remains the same. But if you keep 1D arrays as 1D arrays, then it will do horizontal stacking. Horizontal stacking means it will do this kind of stacking. Okay, but if you convert first 1D array as 2D array by reshaping and then use the same command, then in that case it will do VStack. Okay, so it will do this kind of stacking. So let us do that by one example. First, create a simple 1D array. We have created so many times now that np.array and you will pass a list, and similarly np.array and you will pass a list. Since I am not passing list of list, just a one single square bracket, so obviously this I am creating a one-dimensional array, and you can see that this is the first array and this is the second array. This I have just put so that you can clearly see separated. Otherwise, it looks almost like a 2D array. That's why. Okay. Now print np.concatenate a comma b x is equal to 0. So this time I am not doing any modification to my original 1D arrays. So then what I get, let me first clear the output so that you are satisfied that it is not the old sum output which is saved. Okay, and then you can see that I am getting horizontal stacking. So it is a very simple command, and the command will work for any type of one-dimensional array. Okay, fine. Now if you want vertical stacking, still the command remains the same. In fact, everything remains the same. But before passing to that command, you have to convert your 1D array into a 2D array. So if you compare this A and this A, immediately the difference is clear, that here I am passing as a list of list. So this is now a two-dimensional array which is creating the number of square brackets that is equal to the number of dimensions in my array. And we will see that printout also. Then you will understand. Here I will put these in a new cell so that first we can check the printout and see the difference between A and B with a single bracket and A and B with two square brackets, so that you should understand that how simplest way of creating a converting a 1D array to 2D array is just adding one extra parenthesis, not parenthesis but square bracket. Okay, so if I write it this way, you can see the difference. This was a 1D array 1 2 3. This is a 2D array 1 2 3, and this is also another 2D array 4 5 6. Okay, I can even add that extra line also to create a separation. That this is still these two are two separate arrays. Okay, fine. Now I want to concatenate them, and I am using exactly the same command that you can see np.concatenate. In the parenthesis, I am passing two arguments. First argument is the tuple of the two arrays, and the second argument is the axis is equal to 0. For one-dimensional array, original are one-dimensional array. Okay, I have converted them to two-dimensional now, but still, even for VStack, you have to pass as axis is equal to 0, and you can print them, and you will see that you are getting this kind of output. That is 1 2 3 and 4 5 6. Now let me go back to the cell of previous lecture where we had done VStacking by np.vstack. Okay, and that it is already there here. Okay, so then you can see this was the output by VStack 4 5 6, and of course there I changed the order. So now okay, so then 1 2 3 4 5 6, and here this is the output obtained by np.concatenate axis is equal to 0. That is also 1 2 3 4 5 6. Identical, exactly same output is obtained in both manner. Okay, so I hope that this concatenate method is also preferred by many people. That is the reason is that single command will work for HStack also and VStack also. And even there is another way of doing this. Here I converted A and B into 2D array before bit stacking by simply adding one extra parenthesis. Okay, so at the time of creation of A and B only, I can add that way. But another way is that let me. This is what. Okay, this is just node that we have converted. Let me do the same thing in a different manner. I still want to do V stacking only, but I want to keep original 1D array as 1D array only. I don't want to convert them into 2D array and then use concatenate. So then there is only one option. You have to convert into 2D. Now if I don't want to write two square brackets, then you have to write one square bracket only. Keep them 1D only, but then reshape them. Okay. So if you write it this way, these are at present the two one-dimensional array 1, 2, 3, and 4, 5, 6. Now reshape to 1, 3. Okay, so 1, 3 means one row and 3 columns, and reshape these also to 1, 3. Okay, so let us see what is output of this. That actually gives this way. So this was not a two-dimensional array, but this was now after reshaping, when you explicitly specified 1, 3, then you get a two-dimensional array, and automatically two square brackets are obtained. So obviously, this I have to show that this is what is happening, but you can directly right from the beginning only write two square brackets. So automatically it will be converted into 2D arrays, and then you can use concatenate with axis is equal to 0. So when you write two square brackets, you should not you should remember that actually what you are doing is these two steps. First you are creating 1D array, and then you are doing reshaping. Okay. And then thereafter the steps remain same. np.concatenate a comma b axis is equal to 0, and that also gives the same as vstack. So this is vstack obtained by first keeping arrays A and B as one dimensional and then reshaping them. This is vstack obtained by keeping A and B both as two-dimensional array while creation only, so that reshaping is not required at all. And this is vstack obtained. Where is that vstack? Yeah, this. Okay. So this is vstack obtained by somewhere here, right? This is vstack obtained by using actual vstack command. So either you use vstack command, or you use concatenate and use 2D arrays, or use 1D array and concatenate, but use their reshaped version of those arrays. Choice is yours. Okay, and ultimately same result is obtained. So you get 1, 2, 3, 4, 5, 6. This is the picture. So 3 ways of obtaining vertical stacking. There are even more ways. For example, here one way like this is shown, that this is our old 2 arrays. Let me put this 2, or actually only this much, in a new cell. And this much in a still another cell. And the third way in still another cell. So these are some other methods by which also we can get the same result. This is one method, np.r underscore. Now r was row for row wise stacking. If you saw that picture carefully, then this picture, right? So np.r underscore, that was for this kind of horizontal stacking. But here let us see what that r underscore does with this notation. Rather than passing a comma b in a list, pass a in another interior square bracket none colon. Actually this is also just converting a into a two-dimensional, and this is also converting a into two-dimensional. I will show you also that, but first let us try to get the result. And that gives vstack arrays. Okay, then this is np.array ab. This is also one method of obtaining the stacking. Okay, so that also gives the same thing as the upper one. Okay, and this is still another way of np.concatenate a np.new axis instead of none. Here I am specifying np.new axis. The other argument I am keeping same colon, and b np.new axis, and the other argument I am keeping same colon. Okay, and then print. Then that also gives the same. So these are 3 different ways of achieving the same thing. However, those who have seen carefully, they will say that that is not the same thing in a way, because here this was the same thing. You got same result as what was obtained by vstacking. That means 2 square brackets. Similarly, here also 2 square brackets, and similarly with vstack also 2 square brackets. While here you get the same thing, but 3 square brackets are there. So for that means to know what is the difference of between all this. Originally, These are D, E, and S, D, E, and C. Okay, fine. Then let us write one extra step here. That print D dot shape. Shape command is used to get a dimension of the array. So that gives that it has become a 3D array actually. 2, 1, 3. 2 rows, 1 column, and 3 depth. So it is 1, 2, 3 behind 4, 5, 6 actually. Okay, and then here also if I get the same thing, print D dot shape instead of that print E dot shape, it will also give the same result 2, 1, 3. Okay, 2, 1, 3. And similarly here print C dot shape, that will also give the same result 2, 1, 3. So these are looking same in the output, but I would not call that this is the same result as V state. That's why I kept this separate. While if you consider the output of these here, np dot concatenate AB, axis is equal to 0, and then shape. Okay, so that is just 2, 3. So it is a two-dimensional array. Or for example, another is also similar created here. That will also give same. So what is equivalent to V state, that gives a two-dimensional array. Otherwise, it will not be actually created. It will not be called equivalent to V state. Okay. So these where is the V state thing? Then somewhere here, yes. So vertical stack. Okay. So there also I can add one more line. Vertical stack dot shape. Oh, so one more parenthesis. Okay. So shape, I think it is once again trying to concatenate. That is the issue coming. Just vertical stack dot shape. Okay, it is also 2, 3. Fine. So this is 2, 3. Somewhere here also this is 2, 3, and here also this is 2, 3. So there are 3 ways of achieving vertical stacking. Those others I will not call ways of achieving vertical stacking because they actually create somewhat similar looking result, but their dimensions of the resultant array are different. Okay, so there are 3 ways of achieving vertical stacking. First, you use vstack directly, or use np.concatenate. Okay, and in the bracket tuple of 2 arrays, axis is equal to 0, but both A and B should be 2D array, or keep them 1D array, but use their reshaped version for this. So here A is now my reshaped A, and B is now reshaped A. Then also I can achieve same result as what I got in B state. Fine. So this is one thing. Always create a habit of repeatedly trying to check the shape, because most of the time, while later on when you do machine learning algorithms, then you will always get that error that shape of the array which you pass is say 120, that means 100 row and 20 column, but the model was fitted with maybe 150 rows and 10 column, or maybe 200 rows and 10 column, or something different. Okay, so that is why before passing any array, or later on with pandas you will see that data frame, and before passing data frame or array, multi-dimensional array, to any algorithm, you should always check whether it is in the standard shape or not. Now with concatenate, so far we have done concatenate is used for arrays which was originally only 1D array like this. It is a different thing that if you want to do H-stack kind of behavior, then you keep 1D as 1D only. But if you want to do V-stack kind of behavior like this, then you first convert them into 2D by either reshaping or keeping 2 square brackets. That is a different thing, but originally they were at least 1D array. But let us see what happens if concatenation, same concatenate command is used for array which is right from the beginning more than 1D. For example, these are 2 arrays, 1, 1, 1, 1, 1, 1. So obviously 2 rows, 3 columns, and this is also another 2 rows, 3 columns. Okay. If I do np.concatenate with axis is equal to 0 with this, then it will become this kind of situation. So there the difference is that the first axis, that axis, row wise axis, that is called axis 0. But if I write axis is equal to 1 and concatenate them, then the second axis or the column axis, that is called axis is equal to 1. Always remember this, that from row you start giving the axis numbers. So row wise axis is axis 0, column wise axis is axis 1, and if there is a depth also, third dimension, then the depth wise axis will become axis 2. Here there are only 2 axes. So let us try to create these 2 arrays 1, 1, 1 and 9, 9, 9, and let us check if the so A equals, or why A and B only, just to distinguish, P equals np dot array. Now I want to create array which is two-dimensional right from the beginning. So you know that it should be list of list 1 comma 1 comma 1 and then comma, and then another should be 9 comma 9 comma no, that also should be 1 comma 1 comma 1. Okay, and let us print that p. Okay. So it is that type of array. Similarly, I want to get another which is q. There is only one difference, that instead of all elements 1, all elements are 9. So 9, 9, 9, and here also 9, 9, and 9, and print q. This is my another array, say q. My purpose is to show that for 2D array, what happens if I concatenate along axis is equal to 0 and axis is equal to 1. So say this R is equal to np dot concatenate. If I just write this much and press, you can press, then you can get original q. You can get the name of full command p comma q, and then comma and axis is equal to 0, and then print that R. So axis is equal to 0. I am saying that it will create something like v setting, because 0th axis is actually this. So that means, let us see this way. Okay. So I am getting the result. Okay, fine. Now similarly, s is equal to np dot conca that much, and press the tab character. Immediately you will get the p comma q and comma axis is equal to 1. Okay, and then of course I have not provided anything for the output. So sorry, let me read the end of the chapter. This life is not so easy. Sorry, friends. Yeah. So somewhere here, yeah. So S, and this time you can see that I am getting this type of array. Okay. So here what is happening? The two 2D arrays are just concatenated column wise, or they are placed adjacent to each other and pasted. While here they are placed one above each other and then pasted. Okay. Or in other words, more sophisticated thing, here 2 rows and 3 columns. Then 2 rows and 3 columns. Then when you concatenate it along the row axis, then the column number does not change. So that is why in the resultant array also there is 3 columns only. But row number, if you concatenate along row axis, then obviously row number will increase. So row has become 4. Okay. And if you concatenate along column axis, then whatever you are concatenating along, that will increase. So number of columns will become 6 now. But other does not change. So number of rows does not change. So this 2 also has 2 rows, this also has 2 rows, and the resultant also has 2 rows. So remember this, that concatenation along a given axis always increases the dimension on that axis, but and keeps the dimension along other axis unchanged. Okay. So I can even write that as a note in capital letters, that concatenation along a given axis increases the dimension of resultant array on that axis, but keeps other dimensions constant. Okay, and fine, that is, and let me make this markdown cell and let me execute it. So that it remains in large letters. This is an important statement to remember, because many times before doing concatenation, mentally you have to imagine that I want to get this result, then how I will do it. Okay. Now with that much, I will stop here, and next lecture we will do this depth-wise stacking and splitting of arrays. Splitting is reverse of stacking. Or let us finish the depth-wise stacking. Depth-wise is not seen much, but some people don't even know that there is a command like dstack. Okay, but there is a command, and even this diagram also I could find after a lot of efforts. But if this is one array, now which kind of array is this? This is 3 by 3 array, because it has 3 rows, 3 columns. And if someone says what is the third dimension, the third dimension someone can say it is 1. This is 3 by 3 array. Okay, fine. And this is another 3 by 3 array, and they are placed one in front of another, and then they are pasted like this way. Okay, or if this is front and this is back array, this is the array of all zeros, this is the array of all ones. They are pasted in this manner. Now here you have which axis? Elements are on x-axis, 3 rows, and y-axis, or column axis, 3 columns. So I just now said that if you test or concatenate along the third axis, because this is ultimately concatenating, so you are concatenating along second axis, axis 2, then that dimension will increase. So this has the third dimension 1, and this has also depth dimension 1. So obviously the resultant array will have depth dimension 2. But other dimensions do not change. So no change in rows, no change in column, but this becomes a thicker array. So this is now which type of array? 3 by 3 by 2 array. Okay. So let us do that. And here also I will put this other part in next cell, because too much information in one cell is not good for learning. Okay. So then np dot 0 is 3 by 3. So that will create this array, right? And np dot 1 is 3 by 3 column 3, 3 comma 3. So that will create the back red colored array. And let us print also a and b, and then we will first even this let us take in other. First, I just want to print a and b so that we can be sure that it is exactly like the form of this left side diagram. Okay. So print a and b, and you can get 0 0 0 and 1 1 1. So these are which kind of arrays? Then 3 by 3 arrays, and depth dimension or axis 2 dimension is 1. Someone can call 0, but whatever the dimension is, that will increase by 1. Okay. And now do restaking of those two, just like it is v stake, h stake, similarly d stake. Okay. So if you do that restaking and create the output, then the output would be like this. Now here in this setting it is difficult to imagine, but actually speaking, all this 0 0 0, then this 0 0 0, and this 0 0 0, they are in front. Okay, while all this, that is 1 1 1, the other 1 1 1, another 1 1 1, they are at the back. So this diagram is what it is. And for our confirmation, we can check it by printing its dimension, so that we are sure that because in the output it does not look as clear as that diagram. So print dstack underscore ab, which is obtained by destacking of two arrays a and b. Okay, so print dstack underscore ab dot shape, and then you can see that it is 3 rows, 3 columns, and depth axis, second axis. First is 0 axis, first axis, and second axis has now 2 dimensions. So exactly like this. Okay, fine. So this is what is about stacking. Next lecture about splitting, reverse of stacking.